All right, so picking back up with those trig functions, so far we've only used them to solve for missing sides. But here's the deal. You can use them to also solve for missing angles. So take a look at this triangle. We have side lengths, 3, and the hypotenuse is 10, but we don't know any of the, well, that's not true. We know angle F is a right angle, which is a good thing because then we can use trig. But we don't know what angle D and E are. How am I supposed to figure that out? Well, trig can help you do that. So if I'm looking for angle E here, I'm going to circle it, angle E. If I'm standing at angle E, what is 3 to you? I hope you said opposite. 3 is opposite of angle E. 10 is the hypotenuse because it is across from that 90-degree angle. Now, which trig function, you look, don't be lazy, look, come on. Which trig function has opposite and hypotenuse? You said sine, right? Sine is opposite over hypotenuse. So that tells me I am going to use the sine function. Sine of angle E is equal to the opposite, which is 3, over the hypotenuse, which is 10. Now, listen carefully. How do we get rid of the sine? I just want angle E. You don't divide it. You can't. Okay, it's a function. So to get rid of it, we do the inverse of the function, which literally is written as sine inverse. I kid you not. Sine inverse. It looks like an exponent of -1. So I have to take the sine inverse of both sides. So sine inverse of this, sine inverse of 3/10, because then that sine inverse and that sine, they actually, since they're inverses of one another, they cancel each other out, I guess, if you want to think of it like that. But we are then left with E. But you can't figure out sine inverse of 3/10 by hand. You got to use your calculator. So sine inverse, I'm just going to rewrite it, of 3/10. Okay, this is what you got to do. Listen carefully. Since I literally want the opposite of the sine, I hit second and then I hit sine. Because that means give me sine inverse. And you can see that. Here, I'll erase it. So you can see up above, sine is that sine inverse. That's why we're hitting that second key, because that's the function we want. Sine inverse, and it'll pop up like this on your calculator, and then that parenthesis automatically pops up. And we have 3/10, so we can either do it as 3 fraction 10, if you like that, or you can do 3 divided by 10. Either one, doesn't matter. So 3 divided by 10. And when you hit equals, we get approximately 17 46/100. So E is approximately 17 46/100. So angle E is about 17.5 degrees. Now, if I asked you to find angle D, could you set up a different trig function using adjacent and hypotenuse, cosine? Absolutely, but guess what? You already know there are 180 degrees in a triangle. 180 minus 90 is 90. 90 minus 17 46/100. Okay, you follow me? I probably should have written that down. 180 minus 90. That's 90. So I have 90 degrees left for these two angles. Okay? Angles, not side. 90 minus 17 46/100 gives me my remaining angle is 72. So angle D is 72 54/100 degrees. Okay, could you use trig? Absolutely, but I'm just saying you don't have to. Now, again, I know that most of you probably just don't have a scientific calculator laying around at home. So on Desmos, in those functions right below sine, we have sine inverse, literally meaning the opposite. And it too pops up with that parentheses, and then you can type in 3 divided by 10. And you can see we get the exact same answer. So if you don't even want to go get your calculator because you're sitting down, you're all comfy, then just pull up Desmos scientific calculator and you can figure it out there. All right, let's just run through a couple more examples. I'll do one more with you and then you're on your own. Okay, so this one, angle J, that's what I'm looking for, that's what I care about. Well, 7 is what to J? It's opposite. And 11 is what to J? It's adjacent. okay? Because this would be my hypotenuse. So I have the opposite and the adjacent. Look at your trig functions right now. Which one uses opposite and adjacent? I surely hope you said tangent. Tangent, I'm just rewriting it, is opposite over adjacent just to make my point. Okay, so tangent of angle J is equal to the opposite, which is 7, adjacent, which is 11. So tangent of J is equal to 7 over 11. Now, just like we did with sine, tangent also has an inverse. So to get rid of the tangent, we take tangent inverse of both sides. I hope you're seeing that once you set these up, it is literally just algebra. Like, no joke, just algebra. So I have J is equal to tangent inverse of 7 over 11. I'll run through it one more time on this calculator, but otherwise go ahead and use Desmos. So we would hit the second, and then we hit tangent, because I want that tangent inverse, and then 7 divided by 11. Okay? All right, here it is on Desmos. So tangent inverse, and then it pops up with that parenthesis, just like it shows here. The other one will stay gray. And then we do 7 divided by 11, and then you can close up that parenthesis. And we see that it is approximately 32 and 47 hundredths. So let me go back here. Angle J is about 32 and 47 hundredths. Okay, figure out angle K. I know I didn't ask for it, but I did. So pause here and figure out what angle K is. All right, 180 minus 90 is 90. 90 minus 32 and 47 hundredths leaves me with angle K to be approximately 57 and 53 hundredths. All right, I feel like you got this. You're ready to go. So pause here and try each of these on your own. All right, so for solving for angle D, 3 would be adjacent, 10 hypotenuse, and we could see that we would use cosine for that because adjacent over hypotenuse. Now, solving, doing a little bit of algebra, we get 72 and 54 hundredths. Now, it says, what do you know about this example and the one above it? Well, let me scroll back for you, just in case you forgot. Check it out. It says, what is the measure of angle D? 72 and 54 hundredths. Remember when I showed you how we could solve it because it's just a triangle? And we could use trig, but the triangle is faster. Okay, yeah, it is. But there you have it. You can also use trig. Now, maybe you noticed on the next one, remember how I had you do that too? Using trig, we found K. It was 57 and 53 hundredths. Let's check it out. Let's just verify that we do know what we're doing. Angle K here means that 7 would be adjacent. 11 is opposite, right? Opposite. So that would be tangent of K is equal to, opposite is 11 over 7. Now, to solve for K, we have to take tangent inverse, right? Get rid of that tangent inverse of both sides. Tangent inverse, so I'm left with K is equal to tangent inverse of 11 sevenths. Now type that in, calculate it, do a little decimals, whatever it is. We get K is approximately 57 and 53 hundredths. Does that sound familiar? Because it should. Check it out. Let's go. Let's verify. When we did it the triangle method, we did get 57 and 53 hundredths. So either way, it doesn't matter. The triangle method is a little bit faster rather than doing trig twice, but they both work out. If you want to practice that trig a little bit more, I say go for it. All right, that is a wrap. That's all we're going to do to just introduce you to trig before you move on to Algebra 2. So you're good to go. Go ahead and do the homework for lesson 9.4 and 9.5.